यहाँ से तो फोन है, मैं ये तो फोन कर दिया मैंने यहाँ से, एक बार दबाया है, बस फोन हो गया, ठीक है। और ये वाला अब फॉलो करना है इसमें, तो वो भी ग्रीन हो जाएगी। जी सर, 1 मिनट रह गया बस सर।
Ma'am, is it okay if I write like this?
ठीक है मैं करता हूँ। लीजिए मैडम,
प्रॉब्लम
अब
कर
एक
रही
ही
है।
फिंगर यूज करना है मैडम, इसको लगा लीजिए कोट में, इसको लगा
Yes, ma'am. Ma'am, 5 minutes are left. Application underscore derivatives. अब आप दिखाओगे भी इसी बोर्ड नहीं कर सकते आप। बस कर देंगे मेरे को ये सब। अरे इतना बड़ा लिखना पड़ रहा है वो, लिखा नहीं जाएगा ना पूरे पे, बड़े बड़े एक्सप्रेशन है आज। I'm just okay, good. मैम ये मुझे कंफ्यूजन आज तो मेरे ख्याल भारी आएगा अंदर तो, मुझे नहीं लगता। पीछे से ले लो, वो मत पोट के हाल हटा। एप्लीकेशन अंडरस्कोर डेरिवेटिव पीडीएफ ऊपर वाली। हाँ, अगर कुछ तो दर्द कर रहा है अभी, क्या सारे एक्सपेरिमेंट इन्होंने ऐसे लग रहा है ना, उल्टा तो नहीं लग रहा है, बड़ा ही अजीब सा लग रहा है, दर्द करेगा। क्यों आ रहा है? इससे अच्छा रहता है बोर्ड पर ही रखते क्या। आज आप एकदम एडवांस हो गए टेक्नोलॉजिकली। I won't be able to write big expressions on this board. I'm telling you. Because see, just open the file. Let me show you. Scroll it down and please scroll it down. Don't do next page because it's a Word document. No, it's not a PPT. It's not a PPT. It's actually a Word document. So you will have to scroll it down. It's not.
But in the software it comes as the next pages or each pages.
But even this is, troubling me.
Scroll down now.
Mhm.
Only go up to the
Now look at this expression. Look at this expression, 4 sin x minus 2x minus x cos x upon this. Now it will have another 3 terms like this. I don't feel I will be able to write that on this board with finger.
Then you can camera.
Maybe you can have focus only there. Hmm? You are not comfortable with this. I'm not able to, do like this. ये अच्छा है क्या लास्ट वाले से? ये तो 2 घंटे में मेरे कान में बहुत ज्यादा पेन कर।
नीचे भी प्रॉब्लम क्रिएट कर दिया अभी अभी तक.
What happened with the device we used last time?
Last time we had a camera people here. We have taken
Oh.
the camera people. Right now we are using this camera. So focusing on the board, it is difficult.
Actually, she is not able.
Okay.
मतलब she is
ये
not
थोड़ा ना
comfortable with
पेन
this
कर रहा है
also.
यहाँ पर.
Main issue is
Then what should I do? Should I use board or
ये प्रोजेक्ट है ना.
and where will you show the file there? Yes. आज अच्छा है टाइम. इट्स ऑलरेडी 1. मैंने आके पूछा था कि मुझे कहीं रिपोर्ट करना है क्या.
आपको कब से ढूंढ रही हूँ, सारी बिल्डिंग में ढूंढ रही हूँ.
नहीं नहीं नहीं, मैं तो वो कौन से सर थे उनके साथ साथ आई हूँ. अच्छा फिर
डायरेक्टर मैम के बगल वाले रूम में हूँ.
बैग मेरा यहाँ ही है.
बाई
ओके.
चांस आपको इंटरकॉम करने की जरूरत पड़े तो 207.
मैं तो 12:30 से भी पहले ही आ गई थी.
और मैं कब से ढूंढ रही हूँ.
और मैं ना आपके रूम की तरफ भी आई तो वहाँ एंट्री भी देखी होगी आप.
मैंने रिसेप्शन
तो मैम आज ये सडनली बदल गया ना. कान में ये जो लगाया है, पिछली बार ऐसा नहीं था. एक ऐसे ऐसे फाइनली क्या यही तो
हेलो
कौन है ये? क्या गिर गया?
नहीं
अच्छा,
प्रॉब्लम हो रही है
थोड़ा सा ये टाइट है,
देखो ना मैंने लूज कर दिया काफी और कम करके देखो जरा
गिर ही ना जाए उसके
नहीं
बाद।
नहीं गिरेगा तो नहीं
अगर उसमें कुछ लगा दें पीछे पेपर वगैरह तो एक्चुअली प्रॉब्लम
थोड़ा लूज कर दिया अभी और
एक मिनट इसको ना कान से दूर कर दो बस तो ठीक हो जाएगा।
थोड़ा बेटर है। हाँ,
मैंने पीछे से भी लूज कर दिया।
बस गिरेगा तो नहीं ना।
यहाँ पर जो चुप रहा था ना वो शायद
नाउ इट्स बेटर।
नाम उसको कंफर्टेबल नहीं है।
सर वो बहुत बड़ा एक्सप्रेशन है और मुझे फील ही नहीं आ रही कि वो लिखे जाएंगे। प्रैक्टिस कर लूंगी आज जाने से पहले।
ठीक है
समझ अच्छा लेके आते हैं
मैं टॉप पे लगा बाकी साउंड वगैरह लगा दी सब कर दिया
हेलो,
मैडम को लिखेंगे उसको कैमरे को जूम करके देना
फुल स्क्रीन कर देना स्टार्टिंग से। Hello students. So in our last session, we discussed the concept of continuity and differentiability of a function, right? In today's session, we will learn about application of derivatives. Okay, there are several derivatives which probably the resource person in last session discussed with you, like finding maxima and minima of function, finding the interval where function is increasing or decreasing, okay, and many more applications. We will discuss them one by one in today's sessions, right? So if a function is given to you, you can find its derivative and you can have all the information on derivative of the function. You know that derivative of a function is again a function of the same variable. Okay. Now, if the derivative of a function is known to you, can you find the function? By integrating the derivative function, and then you can have information about the function. But if the function is not known to you, in fact, the derivative function is not known to you, but you have some information about the derivative, still you can gather some information about the function. This is one of the applications of derivatives. Okay, so first such application is about increasing and decreasing functions, that is discussing the monotonicity of a function, finding the interval where function is increasing, where it is decreasing. Okay, So first of all, let's learn what we mean by increasing function and what we mean by decreasing function. Okay, so increasing function means as x increases, as your variable increases, the value of function also increases. Okay, so it may happen that function is increasing on some interval whereas decreasing on some interval. So we always talk about increasing and decreasing function on some set. Okay, so consider a set, say A, contained in the domain of the function, right? We say function is increasing on the set A if x1 less than x2 implies fx1 is less than fx2. Okay, and this should be true for all x1, x2 in the set A. If the function possesses such a property, we say function is increasing. Okay, so now graphically what it means, if say this is your set A and you take one such pair x1, x2, what we are saying that fx1 should be, this is fx1, this is the point x1 comma fx1. So this point should be at higher position. Okay, so you can say the graph should rise. Fine, for an increasing function. Now graph can rise in this way or in this way or in this way, right? In all these three curves, you can see whenever you take x1 less than x2, this is a straight line. Okay, assume this is a straight line. What we have, the value of fx2 is higher than the value fx1. Okay, so do you find any change in these three curves? It's the banding of these three curves, right? So this banding is known as concavity of a curve. Okay, now see that this is a function which is differentiable at every point because it is smooth, right, which we discussed in last lecture. So if you take tangent here, the angle it is making with positive direction of x-axis is acute or obtuse? Just tell me, is this angle less than pi by 2 acute, right? You take any point anywhere, it will be making an acute angle. Even in this situation, anywhere it will be making an acute angle. Okay, so this angle will be between 0 to pi by 2. And what is the sign of tan theta in the first quadrant? Positive. And tan theta gives you the slope of the tangent, where theta is the angle the curve makes with the positive direction of x-axis. So what you get, tan theta will always be positive, and tan theta is the slope which is also given by f dash x at the point x, right? So what information we have? F dash x must be positive. Okay, so if f dash x is positive, then function is increasing. If f dash x is positive for all x in the domain, in the set, then function will be increasing. Fine. Now look at this curve. Now what is happening here? If you take x1, x2 in this portion, then fx1 and fx2 are equal. Okay, whereas in this portion, if you take x1 and x2 here, then fx1 is smaller than fx2 as well as here, right? So when x1 is less than x2, this time fx1 is not less than fx2 for all x1, x2, rather you have this inequality. Okay, so all these four cases are of increasing function, but these first three cases where you have strict inequality, we call such functions to be strictly increasing. Okay, whereas this function, this kind of function, we call such functions to be only increasing, not strictly increasing. Okay, now consider these curves, first three curves.
here what we observe, now I am talking about the concavity, the bendingness. When you are here, this angle is acute, but when you move up, the angle increases a bit, right? So when angle increases, in the first quadrant angle increases, then tan function increases or decreases? Increases, right? Tan function is increases. How does the graph of tan function look like? If this is pi by 2, then it is like this, right? Like this. Fine. So in the first quadrant, 0 to pi by 2, as x increases, the angle increases, the function tan theta increases. So what you have, the tan function is increasing. Tan function is increasing means slope function is increasing. Slope function is the function f dash x. So if f dash x is increasing, what you will have? Its derivative function will be positive. What we discussed just now, that if a function is increasing, then its derivative must be positive in that interval, right? So if I am saying that here f dash is increasing, that means its derivative, which is f double dash, must be positive, right? So if f double dash is positive for all x in this interval a, then we call such function to be concave up. Okay, concave up, right? Vaguely I can say concave up are such kind of shapes which can hold water. If I pour water in this, it will not fall down. Some water will be collected here. Okay, whereas in another shape which I had drawn like this, if you pour water here, it will all fall down. Okay, and here if you look at the slope function, here you have this angle, here you have this angle. So what is happening? The angle is decreasing, right? So if in the first quadrant angle is decreasing, slope function is decreasing. Okay, slope function is decreasing means its derivative further will be negative. Okay, so if f double dash x is negative for all x in A, we say the function is concave down. Okay, function is
decreasing.
No, function is not decreasing. See, function is increasing because f dash function is positive. F dash is positive, but the rate of change of f dash is negative. Okay, that means f dash function is decreasing. Okay, so in this case, when the function is increasing and concavity is up, then f dash is positive and rate of change of f dash is also positive. That is, f double dash x is also positive. Whereas in this case, when the function is increasing, but its concavity is down, it's concave down, then f dash x must be, tell me, positive or negative? Positive. But its rate of change must be negative. Okay, so this is concave up, this is concave down. This concept will be further useful to you in discussing the notion of maxima and minima, but right now I am not touching it. So this is about increasing functions and strictly increasing functions. Okay, similarly we have notion of decreasing functions. Okay, so just analogous to this, decreasing function will be function where x increases but the corresponding value of f decreases, right? And if we have strict relationship here, we will call such function to be strictly decreasing. And if you have this inequality, then we will call such function to be only decreasing. Okay, in some books you may find that they call this function as non-increasing because it is not increasing. Okay, and the previous case of only increasing, they are also known as non-decreasing function. Okay, so such shapes will be like this or like this or like this. And for non-decreasing you will have, sorry, non-increasing case you will have something like this. Okay, so here what do you think, its concavity is up or down? Clear? Concavity is up, right? So quickly tell me what should be the sign of f dash x here? Negative. Good. And what should be the sign of f double dash x? Concavity is down. And here f dash x will be negative, but f double dash x will be positive. Okay, even you can check this with this slope function. Here this is this obtuse angle, here the angle will be reduced, and in the second quadrant when the angle reduces, tan function. Now think about it. Okay, so clear? All the definitions clear to you? Okay, can you please show the slide? Okay, so if a function is increasing in the whole domain or it is decreasing, we call such functions to be monotonic functions. Okay, it may happen that function is increasing in some interval but decreasing in other part of the domain. Okay, so such functions are not called monotonic. A monotonic function means either it is increasing throughout or decreasing throughout, and if it is strictly increasing or strictly decreasing, then we call such function to be strictly monotonic. Okay, so look there, monotonic functions are functions which are either increasing or decreasing. Okay, now we have a notion of critical point. A point x is equal to a in the domain is called a critical point of the function if derivative at that point is 0 or it does not exist. Derivative at that point does not exist. Why? For example, look at this function. Derivative will be 0 at this point, right? Look at this function. At this point, derivative does not exist. You can see through these examples that function changes its nature only at such points. Okay, nowhere else it can change. If derivative is positive throughout or negative, then there this nature will not change. Nature can change only at such points where the derivative is not defined or it is 0. Okay, but why critical? Because it's not sufficient condition that if you have a critical point, then there necessarily there the nature changes. For example, look at this function x cube. So in here at 0 the derivative is 0, but the nature is not changing. Okay, it's keep on increasing, keep on strictly increasing. Fine. So these points are called critical points. These will be helpful in finding the interval of increase and decrease. Okay, so what will be the method? We will find the critical points. We will divide the domain with the help of those critical points in some subintervals, and then in each of the subinterval we will check the sign of derivative function to know where the function is increasing, where the function is decreasing. We will learn that with examples. Now stationary point, a function is said to have stationary at x is equal to a if its derivative at that point is 0, it vanishes. Okay, next slide please. Scroll it down please.
How can we decide that if f is equal to 0, then it is a critical point or a stationary point?
See, every stationary point is a critical point as well, right? But converse is not true. Okay, because Stationary point is where the derivative vanishes. And critical point has something more. Even if derivative is not defined at certain point, that point is also a critical point. So every stationary point is a critical point, but not conversely. Now, some properties of monotonic functions which will be helpful in solving problems. So if fx is strictly increasing function, then can you tell me if it will be 1, 1 or not? If you have a strictly increasing function, then it will always be 1, 1. Okay, because never you can get the same value for two different values of x. Okay, so this will always be 1, 1. And then you know 1, 1 function is invertible. Okay, invertible on the range set. And so what the result is, its inverse will exist. Moreover, the inverse will also be a strictly increasing function. Okay, you know how to find the inverse of a function geometrically. You take the mirror image of this curve in the line y is equal to x. Okay, so if you take its mirror image, this will be the curve of f inverse function. Okay, inverse function. So you can see this is also strictly increasing. Likewise, you have for decreasing as well. Okay, so it is strictly increasing. If the function is increasing, only increasing, in that case, it may not be invertible, right? For example, a constant function, this is a increasing function in a way. Okay, it is not invertible because at all these points it's taking the same value. Fine. Moreover, if your function is continuous, inverse function will also be continuous. Okay, next result is if one of the two functions f and g is monotonically increasing, okay, and another is also increasing. If both the functions are monotonically increasing, then their composition function is also increasing. Likewise, if both the functions are decreasing, their composition function is also decreasing. We can quickly verify this. If x1 is less than x2 and both f and g are increasing, then I'm talking about the composition function g of f. Likewise, you can do for f of g. So since g is increasing, gx1 and gx2, what will be the sign here? Gx1 will be less than gx2. Now think of this as some y1 and this as some y2. So if y1 is less than y2, I should first operate f because I am talking about Goff function. So if y1 is less than y2, then g of y1 will be less than g of y2. Why? Because g is increasing. And this I can write as GOF of x1 is less than GOF of x2. So I started with x1 less than x2 and I end up with Goff of x1 is less than Goff of x2. What it means? This function is increasing. Okay. Now if both the functions were decreasing, then x1 less than x2 will imply fx1 is greater than fx2. Okay. Now this point is bigger than this point. And g function is also decreasing. So again the sign will change. Okay, so you end up with the same situation. Okay, so Goff function is again increasing. So if both f and g are increasing or decreasing, then the composition function is always increasing. Okay, and the next result is if one of them is increasing and other is decreasing, then the composition function always decreases. Okay, and these results holds even if you have equalities here. Okay, so do I need to show that or you can do that on your own? Sure? Or it will take only few seconds if you want. So you can try that on your own. It's an easy job. Okay, so we will be using this result. Can you scroll it down? Okay, so no. Okay, the next one. Okay, so now some points to remember, some concepts that will be useful to us in solving problems. If f dash x is greater than equal to 0, what does this mean? The function is increasing. And suppose f0 is 0, that is the function is passing through origin. Okay, it's an increasing function and passing through origin. Then graphically also you can see if x lies in the positive part of the real line, then fx and f0, what should be the relation between them? Fx should be greater than f0. And if x lies on this side, then fx should be smaller than f0. Okay, so this was the first result. Similarly, if the function is decreasing, that is f dash x is less than equal to 0 for all points in the domain, and the function is passing through origin. Okay, in all possible ways you will have this situation. And then if x is in 0 to infinity, then fx will be smaller than f0, and if x is less than 0, then fx will be greater than or equal to f0, which is 0 in this situation. Okay, so these were two properties which will be helpful. Then next result is, can you show? Okay, so the concept of increasing and decreasing functions is also helpful in comparing two functions. Comparing two functions means out of the two functions, which one is bigger or which one is smaller. Okay, so if fx and gx are given two given functions to you, the general method will be, we will be considering a new function by taking the difference of two functions. You may take gx minus fx. Okay, and then we will discuss about this function h, whether this is increasing or decreasing. Okay, method will be more clear to you when we will be doing problems. Now next result is about cubic polynomials. In general, a cubic polynomial is of this form, right, where a is not equal to 0. Good. Otherwise it will be a polynomial of smaller degree. Then to discuss its increasing or decreasing behavior, what we should do? We should first find its derivative. Okay, so this will be 3ax square plus 2bx plus c. Now this is a quadratic polynomial. Fine. Now to find the behavior of the function, we find first the critical points. Okay, critical points are actually the roots of this function. Because this is a polynomial function, it will be defined at all points. You will not have that case where derivative is not defined. So all critical points will be the root of this equation, right? And the roots, the number of real roots can be determined by looking at the discriminant of this function. Okay, so if discriminant is positive, you will have two real and unequal roots, say alpha and beta, where alpha and beta are not equal. Fine. Then my f dash x can be expressed in this form, some constant time x minus alpha into x minus beta, right, where the sign of k will depend on the coefficient of this term. If a is positive here, k will be positive. If a is negative here, k will be negative. You can bring this in this form, right? Now look at the sign of, so what are the critical points here? Alpha, beta. So what we will do? We will divide the whole real line, the domain, in three parts. Okay, when x is less than alpha, when x is between alpha and beta, when x is greater than beta, right? If x is less than alpha, then x is less than beta as well. Fine. So what about this factor? X minus alpha will be smaller than 0 or bigger than 0? Smaller than 0. Likewise, x minus beta will also be less than 0. Fine. So x minus alpha into x minus beta will be greater than 0. Okay. Now here, when x lies between alpha and beta, x minus alpha will be positive, and x minus beta will be negative. So that the product is negative. And again here, in this case, x will be bigger than alpha as well. So x minus beta as well as x minus alpha is positive. So that product is positive. Okay. Whatever the sign of k is, whether it is positive or negative, if k is positive, then the sign of f dash x will remain positive, negative in this portion, positive in this portion. Fine. And if k is negative, then you will have negative sign here, then positive and negative here. That means the nature of the curve changes. It will be increasing, decreasing, increasing, or decreasing, increasing, decreasing. So it cannot be monotonic. Fine. So one thing for sure, if this cubic polynomial is monotonic, then discriminant cannot be greater than 0. Okay, this result will be really helpful in solving problems. Now, if the discriminant is 0, even you can have idea of this about this function, whether how it will look like. Function will be like this. It's first increasing, then decreasing, then increasing, or decreasing, then increasing, then decreasing. And at these points, derivative is 0. So these are basically the roots of f dash, alpha and beta. Okay. Now, if the discriminant is 0, what we have? We will have equal to equal roots. Fine. So f dash x will be some constant time x minus alpha whole square. Fine. This factor, no matter where x lies, this factor will always be positive. Fine. So if k is positive, the function will be increasing throughout. If k is negative, function will be decreasing throughout. So this is possible. Okay. And situation curve will look like this. Okay, it may not pass through some fixed point. So it will be like this. Little bit flat, just like the curve x cube. If it is increasing, or like this, if it is decreasing. And at this point, you will have the root. Okay, repeated roots, both roots lying at the same point. Okay, so this situation is permissible. And if the discriminant is smaller than 0, that means f dash x has no real root. Okay, so whatever the sign of f dash will be at some point, it will remain same throughout. Okay, then the sign in case of polynomial, see, f dash x is a polynomial. Maybe I'm taking ax square plus bx plus c. You may have different coefficients here, right? Now, in case of polynomial, limit at certain point, limit at infinity can be found by just looking at the sign of the leading term. Okay, how? Because if I take a common, in fact ax square common, I will be left out with this. Okay, this I can do because a is non-zero. Now when you take limit extending to infinity, this factor will go to 0, this factor will go to 0. So limit inside of the term inside bracket is 1. Fine. And limit of this term will be, it's going toward infinity, right? So if now a is positive, it will be going to plus infinity. If a is negative, it will be going to minus infinity. So when you get the sign at some point and it is not changing, it will remain throughout the same. Okay, so tell me if this situation is permissible or not for your function to be monotonic. This is also possible. Okay, so if the function, a cubic polynomial, not any general polynomial, we are talking about a cubic polynomial only. If a cubic polynomial has to be monotonic, the discriminant of its derivative must be less than or equal to 0. Greater than 0 situation is not permissible. Okay, so now we are ready to solve problems. So please scroll it down. So what is the general method to find the interval of decrease? Increasing and where function is increasing or where it is decreasing. First find the critical points, right? Divide your domain in some subintervals and then you check the sign in each of the subinterval. So first problem is fx is 4 sin x minus 2x minus x cos x divided by 2 plus cos x. And what is the domain? It's given to be the open interval 0 to 2 pi. Okay, so we have to check the intervals of increase and decrease only in this part. We don't bother about what is happening outside this interval. So see, now what you will do, you will start computing its derivative. And this is quite a big expression. You will be applying quotient rule. You will have much bigger expression. Okay, so try to simplify the things as much as you can. Now, if you look at this part, I can write it as 4 sin x minus, take x common, 2 plus cos x upon 2 plus cos x. So if I separate these terms in the numerator, this will be cancelled out in the second term. So I'm left with 4 sin x upon 2 plus cos x minus x. Okay, now you find the derivative. So what is f dash x? Apply quotient rule here. So derivative of the numerator, which is 4 cos x, denominator as it is, right? Then minus derivative of the denominator, which is minus cos x. So minus minus make it, minus sin x. So we have plus sin x into numerator divided by square of the denominator. All right, minus 1. Okay, now you take LCM. You simplify this, try to form factors for this expression, because then only you will be able to compute the sign. So solve it. So what we get? 8 cos x plus 4 cos square x plus 4 sin square x. Then you can see this will become 4 using the identity cos square x plus sin square x is 1 minus square of 2 plus cos x. So 4 plus cos square x plus 4 cos x. Okay, divided by, see, this denominator is always positive. So this is not going to affect the sign. So you can, in fact, because you don't have to show the solution there, you may not write this term again and again. It takes time. Okay, this is the benefit when you have to just mark the answer. So I will be now writing numerator only. Okay, so what I have, 8 cos x plus 4 minus 4 cos square x minus 4 cos x. So 4 gets cancelled and we are left with 4 cos x minus 4 cos square x. So you have 4, anything wrong? Minus, okay, good. Thanks for correcting me. So 4, not 4, taking cos x common, we are left with 4 minus cos x upon, okay. So in the denominator, you have positive term only. Now cos x is bounded by 1 and minus 1. So whatever x is, at the most, this term can be 1. So this term will remain positive. Okay, this factor is not contributing, this is always positive. So the sign of derivative, this will be the final expression you will get. So this is also positive. So the sign is decided by the sign of cos x. Okay, now in 0 to 2 pi, you check where cos x is 0. At pi by 2 and 3 pi by 2. So my domain 0 to 2 pi is divided in 3 parts by including these 2 points. Fine. Now when x is here, cos x is positive. Positive, that means f dash x will be positive and function will be increasing. So let's put this mark to show function is increasing. Here cos x is negative, so function is decreasing. Here increasing. So what I have, increasing in 0 to pi by 2, union 3 pi by 2, 2 pi, and decreasing in the middle portion. So option A is correct. Okay, next please. Now next function is fx is equal to mod x minus 1 plus mod x minus 3 plus mod x minus 5. Okay, is this function differentiable everywhere? No. At what points it is not differentiable? 1, 3 and 5. Okay, so for x not equal to 1, 3, 5, what will be the derivative of this? Using algebra of differentiability, the derivative will be sum of the derivatives of each of them. Derivative, see, this function is not differentiable only at 1. Elsewhere it is differentiable. But perhaps you have not learned what the derivative will be. So first of all, let's discuss the derivative of this function mod x. At 0, it is not differentiable. What is this function? X if x greater than equal to 0, minus x if x is less than 0. So if x is any point in this range, in this domain, x is greater than 0, what will be the derivative? Derivative of this function, which is 1. So if x is greater than 0, derivative will be 1. You can compute that using the definition. X plus h will be x. Value at x plus h will be x plus h, and value at x will be x. So x plus h minus x by h limit will be 1. Okay, and here it will be minus 1. At 0, it is not defined. Okay, now I can, in terms of x, I can write this one as, combining these two, I can write it like this, mod x by x. When x is positive, mod x will be x. So x by x will give you 1. Fine. And when x is negative, mod x will give you minus x. So minus x by x will give you minus 1. Okay, so derivative of mod x is mod x by x. Now can you tell me what will be the derivative of this? Obviously at points different from 1, what it will be? Mod x minus 1 by x minus 1 plus mod x minus 3 by x minus 3 mod x minus 5 by x minus 5, right? Now this function is clearly not defined at 1, 2 and 1, 3 and 5. So those are obviously critical points, right? Now what values this function is taking? Either 1 or minus 1. This as well, 1 or minus 1, 1 or minus 1. Okay, so no combination can give you 0. Okay, either you will have minus 1, minus 1, minus 1, 1, 1, 1. You can take all permutations, combinations. You will never get f dash x as 0. So what are the critical points? 1, 3 and 5. Right? Now if x is lying in this portion, if x is smaller than 1, it will be smaller than this as well as smaller than this. So this number will be negative. For x smaller than 1, this will be minus 1. For x bigger than 1, it will be 1. So this term will be, if x is less than 1, this term will be minus 1. This term will be minus 1. This term will be minus 1. right? So f dash x will be negative. So function will be decreasing in this portion. Okay, in 1, 2, 3. Now this will be plus 1, this will be minus 1, this will be minus 1. So again negative. Now look at this portion 3 to 5. This will be plus 1, this one will be plus 1, this one will be minus 1. So this time you have positive sign. So function is increasing and x is greater than 5. All three will be plus 1. So again f dash x is positive. So it is increasing. So function is decreasing when x remains less than 3. Okay, that is in minus infinity to 3 function is decreasing, and in 3 to infinity function is increasing, which is option B in both cases. Okay, so next example, if fx is given to be this function and it is increasing, then where should a belong to? Is it a polynomial? No. Had it been a polynomial, we could have used that result, discriminant, using discriminant, but this is not a polynomial. So we will use the usual approach. So fx is twice of exponential x minus a times exponential minus x plus 2a plus 1 x minus 3. Okay, and it is given to me that it is increasing for all x. That means its derivative should be greater than 0 throughout. So using that condition, we have to find what a should be. Okay, so find f dash x. This will be twice ex plus ae minus x plus 2a plus 1. Then you have to factorize it. Okay, if I take this term and this term, I get twice of ex plus a. And if I take e minus x common from this, see, I can write one as ex into e minus x. So this is a trick. You will learn it by practice. So if I take e minus x outside, I will get from this term and this term a plus ex again. So that it is twice 2 plus e minus x into ex plus a. Now, no matter what x is, exponential minus x is always positive. Is that clear? No doubts? Okay, so this factor is always positive. So f dash x will be positive if this factor is also positive, right? So if ex plus a is greater than 0, it amounts to say that a must be greater than minus of ex, right? Now a should be such that it is greater than all possible values of this, right? A will be greater if I find the largest value of this expression, and if a is greater than largest value, then it will be greater than any other value as well. Okay, now how the graph of minus ex look like? Ex is like this, minus ex is reflection in x-axis, so it will be like this. So what is the largest possible value? It's approaching to 0, right? If you find its limit at minus infinity, that will turn out to be 0. Okay, so if a is greater than or equal to 0, f dash will be having positive sign. So this is our option A. Okay, next please. So these are some methods you will learn these by practice. Okay, now next problem is, now g is given in terms of f. G is a composition function of f and the function inside the bracket, right? We have to check where gx is increasing. So we will find derivative of g as usual. So gx is f of and f is given to be differentiable. In fact, twice differentiable, so chain rule is applicable. So you remember what is chain rule, and domain is 0 to pi by 2. Domain is also helpful, you cannot neglect it. Okay, so what is g dash x? F dash this as it is, then derivative of this expression. So this will be 2 tan x sec square x minus 2 sec square x. Anything else? No. Okay, so this is f dash evaluated at this expression into, I can take 2 sec square x outside, inside I will have this. Fine. Now I have to identify the sign of these three expressions. Is this contributing? This is always greater than 0 because square of subterm. Okay, now usual technique is to form some perfect squares, because you know if term is perfect square, then it is always greater than or equal to 0. Okay, now what we have not used so far, the condition that f double dash x is greater than 0. What does it mean, f double dash x is greater than 0? F double dash is derivative of f dash. So if derivative of f dash is positive, what information we have about f dash? F dash is increasing. Now value at 3 is given to you. F dash 3 is 0, right? And f dash is increasing. So if x is greater than 3, f dash x will be greater than f dash 3, that is 0. And if x is smaller than 3, then f dash x will be negative. So I have to evaluate f dash at this expression, right? So try to make it something larger than 3 or less than 3. Now if you can look here, I can complete this square by adding and subtracting 1. Fine. So this, if you write 4 as 1 plus 3, then this whole can be written as 10x minus 1 whole square plus 3. No matter what x is, this term is always greater than equal to 0. Okay, if 10x is 1, then this will be 0. 10x is 1 at x is equal to pi by 4 in this domain, right? So at all other values of x, that is 0 to pi by 4 and pi by 4 to pi by 2, because at pi by 4 you will have this term is equal to 3. Okay, at all other values, this expression is, this term is strictly greater than 3 and f dash is increasing. So this will be greater than f dash 3, which is 0. So this is greater than 0. Okay, do not bother about where it is negative, because I have to find where gx is increasing. So this is positive, this is positive. Now I have to see where this term is positive. Okay, now 10x is positive when this, sorry, not 10x is positive. I have to check where 10x is greater than 1. After pi by 4. So out of this portion, in this portion, this factor will be positive. So this function is increasing in the option D. That is when x belong to pi by 4 to pi by 2. Clear? Now, this problem, we have to identify which of these 4 options are correct. More than one option may be correct. And what information is given to me, that f dash x is greater than 0, g dash x is smaller than 0. F dash x is greater than 0 means function f is throughout increasing. G dash x is less than 0 means g is throughout decreasing, right? So we just discussed one result, that if f is increasing, g is increasing, if one of the functions f and g is increasing, other is decreasing, then the composite function is decreasing. Okay, and if both functions are increasing, composite function will be increasing, and if both functions are decreasing, then composition function will also be decreasing. So in first option, we have to observe about fog. F is increasing, G is decreasing, so F of G will be decreasing, right? So X is smaller than X plus 1, F of G is decreasing. So F of G of X should be greater than fog of this. So in the first option, we have the same sign. So option A is correct. Now second option is asking about FOF. F is increasing, so composition should be increasing. So X plus 1 is greater than X. So F of X should be less than F of F at X plus 1, which is again the second option. So second option is also correct. Okay, then the third one involves G and G. G and G both are decreasing, so GOG is also increasing. Both are decreasing, so GOG is decreasing. So X less than X plus 1 means GOG of X should be less than GOG of X plus 1, which is option C. So this is also correct. And GOF, G is decreasing, F is increasing, so GOF is decreasing. So if X plus 1 is greater than X, GOF of X plus 1 should be less than this. So all four options are correct. Okay, all the options are correct. Okay, next. So F and G are increasing and decreasing functions respectively. What does it mean? The function F is increasing, function G is decreasing, and the functions are from 0, infinity to 0, infinity. So F is this function which is increasing throughout, and G is this function which is decreasing throughout. Now from here, if you only look at this portion, F is taking this interval to this interval. That means all the values in the range are greater than equal to 0, right? And here as well, all the values of G are greater than equal to 0. Fine. Now this function is increasing. So when X is here, X can only be greater than 0. X cannot be less than 0. And function is increasing. So if X is greater than 0, what I have, Fx will be greater than or equal to F0. Okay. So F0 will be the smallest value for F. And here, this function is decreasing. So for all X greater than 0, Gx will be, that means G0 is the largest value. Now, what is the problem? The function h, which is defined as the composition of Gx. F is increasing, G is decreasing. So what information we have about h? It is decreasing. So h is decreasing. Also, it is given to me that h0 is 0. So when I put 0 here, h0 will be f of g0. Now what should, and this is given to me 0. Okay, f at g0 is 0. Now if x is greater than 0, since what I have, gx is less than or equal to g0, and f is increasing function. So when I apply f to this, f of gx will be less than or equal to f at g0. What is f at g0? 0. So what I have, f operated at gx for all values of x is less than equal to 0. But we also have this information that f at any value of x is greater than equal to 0. So if in particular I put gx here, what I have, f g x is greater than equal to 0. From one side I have this, and then I have this. So what is the only possibility? F g x must be 0. Okay, so f g x must be 0, or we can say the function h is the constant function 0. It means h of x is 0. Okay, so we have to now find the difference hx minus h1. What is hx? 0. What is h1? 0. So no matter what x is, this difference is always 0. So option A is correct. Okay, now next problem. So hx is given to be fx minus square of fx plus cube of fx. Okay, then I have to see where hx is increasing or where it is decreasing. Okay, so as usual, we first compute h dash x. So this will be f dash x minus, apply chain rule here, twice of fx into f dash x plus, again applying chain rule, thrice of fx into, thrice of fx square into f dash x. Okay, so f dash x taking common, we have 1 minus 2 fx plus 3 fx square. Okay, so now we have to find sine of this thing. Okay, so again try to make it a perfect square, something plus minus of that. So first, what is the procedure? First make the coefficient of this one. So take 3 outside. So what I get? 1 by 3 minus 2 by 3 plus this. Fine. Then so it is fx square minus 2 by 3 fx plus 1 by 3. So to make it a perfect square, we add and subtract. First you divide this coefficient by half and then take the square of that. So 1 by 3 square. So plus 1 by 9 and minus 1 by 9. So this term is now fx minus 1 by 3 whole square. And this factor contributes 2 by 9. Right? 3 by 3, 3 minus 1, 2 by 9. So this is always greater than equal to 0. And this is a positive number. So this factor is always greater than 0, strictly greater than 0. 1 by 3 is a positive real number. So sine of h dash x depend on sine of f dash x. If f dash x is positive, h dash x is positive. If f dash x is negative, h dash x is negative. That means h will be increasing or decreasing according as f is increasing or decreasing. So option A is h is increasing whenever f is increasing. True or false? True. H is increasing whenever f is decreasing. True or false? False. Option C is correct. Option D is nothing can be said. We can very well say something about this. So option D is wrong. So correct options are A and C. Next problem. Okay, now in this problem, this is the problem which I was talking about earlier, that if you have to compare two functions, then the general technique is forming a new function by taking their difference. I have to compare the two functions f and g. Okay, so define a new function hx to be the difference of these two. For all x in the domain is the set of all real numbers. Okay, so we take hx is equal to this. Now h dash x will be f dash x minus g dash x using algebra of derivatives, right? Now it is given to me that for all x, all real numbers x, f dash x is greater than g dash x. So this is strictly greater than 0 for all x in R. And what it means? The function h is increasing. Now another condition given to me is f0 is equal to g0. So how to use that? We can compute h0. H0 is f0 minus g0, and since these two numbers are equal, this is 0. So h0 is 0. So we did this result. If h is increasing and h0 is 0, then for positive values of x, hx will be greater than 0, and for negative values, hx will be smaller than 0. So hx, which is fx minus gx, this will be greater than 0 for all x in 0 to infinity, and this will be less than 0 for all x in minus infinity to 0. That means fx will be greater than gx for all x in 0 to infinity, and fx will be less than gx for all x in minus infinity to 0, which is option A. Okay? Clear? Everything clear so far? Okay, so next problem is, next please. Okay, so again we have to compare two functions. What is fx? Sin x plus 10x. And what is gx? 2x. We have to identify relationship between them. Okay, so again we will use the same technique. Consider a new function hx to be the difference of these two. Actually, I have combined two problems in this problem. To find the true option in A and C, we will consider this function, and to find the correct option out of B and D, we will again construct a new function. So sin x plus 10x minus 2x. Okay, so what is h dash x? What is h dash x? Cos x plus secant square x minus 2. Now if you write it like this, cos x minus 2 plus secant square x, this is always greater than equal to 0. What about this factor? Cos x is always smaller than 1, right? So this number will be a negative number, okay, but is not fixed, right? So if this negative number is greater than this positive number, the answer will be negative. And if this negative number is smaller than this positive number, answer will be positive. So this information is not going to help me in any way. Okay, if you have product of a negative and a positive number, you are sure that the product is negative. But if you have a sum of a positive and negative number, you are not sure whether this number is positive or it is negative. So this is not going to help me. If there is some method so that I can reduce it to perfect square or something like that, combination of a perfect square and some positive or negative term, then it will be helpful. Now, what I know that cos x is less than 1 in 0 to pi by 2. Domain is open interval. In 0 to pi by 2, we have cos x is strictly less than 1. At pi by 2, you have equality. And when a number is smaller than 1, its square is even smaller. So cos x is greater than square of cos x. Okay, so this is greater than cos square x plus secant square x minus 2. Is this step clear? For x in 0 to pi by 2, for all x in 0 to pi by 2, what I have? Cos x is greater than cos square x. So adding these two numbers on both sides, I have this relationship. Okay, now I can write this as, I can add and subtract 1. Fine. And not actually what you will require. if I'm trying to reduce it to cos x plus secant x square, something of that form. So, okay, no need to do this. I can write it as minus 2 cos x into sec x, because cos x into sec x is 1. So what is this? A square plus b square minus 2ab. So this is cos x minus sec x whole square. Now for all values of x, this will be greater than equal to 0. So looking at the smallest sign, h dash x is strictly greater than 0. So h dash x is strictly greater than 0 in this interval. Now in this interval, x is greater than 0, right? So hx will be greater than h0. Now what is h evaluated at 0? Sine 0, which is 0, plus tan 0, which is 0, minus twice of 0. So h of 0 is 0. So what I have, hx is greater than 0. Hx is greater than 0 means sin x plus tan x is strictly greater than 2x. Okay. Now if this method does not strike you, there is another way to solve this. I need to find the sign of this function. Okay, so what I do, I again now assume it as some function gx. So take gx to be cos x plus secant square x minus 2. And now I see its behavior. So what is g dash x? Minus sin x plus 2 sec square x tan x. Fine. So if you reduce it to sine or cos term, what you will have? Sin x by cos cube x. Fine. So this is sin x into cos cube x minus 2 over cos cube x. Now in first quadrant, all trigonometric ratios are positive. So this is positive, this is positive. And cos cube x is always smaller than 1. So this is always negative. Now you have positive into negative. So for sure it is negative. So g dash x is negative. What information it gives to you? That gx is decreasing. Gx is decreasing means for x greater than 0, gx is less than g0. Now what is g0? Cos 0, 1, sec square 0, 1, 1 plus 1 minus 2. So g0 is 0. So for all values of x in 0 to pi by 2, gx is less than 0. And what is gx? Gx is actually h dash x. So h dash x is negative, which again means hx is decreasing. So this is another way. Okay, this is helpful sometimes. Where does this is negative, this is positive, this is positive. So this whole expression is yes. So I have taken sin x. Okay, it will be 2 minus. It will be okay. So we are actually getting increasing function. Okay, yes. And if you look carefully, earlier we got the sign greater than 0. So I made this mistake. So don't do such kind of things. Don't try to skip steps. So you have what? This is greater than 0. Okay, so this is greater than 0. Thanks for correction. So hx is increasing. So hx is greater than h0. Okay, so similarly you can do the other part in option B and D. You can find that option B is true by considering the function 2 sin x plus tan x minus 3x. Okay. Okay, so next problem is for x belonging to this semi-open interval 0 to a, it is given to me that this function, if I call the function on left hand side to be fx, fx is greater than equal to 6. So say 6 is some gx, constant function 6. So it is given that fx is greater than equal to gx. And I have to now compute the value of a, right? So again, what would be the technique? Same technique. Consider the difference function. Okay, find its derivative, and then when you compute the difference function, which is 4x plus 8 cos x minus 4 log cos x into 1 plus sin x plus tan x, quite a big expression, minus 2 sec x minus 6. If you compute its value at 0, what it will be? 0, 8. This will give you 0. So 1, this is 1, log 1, 0. So this term is 0. This is 0. This will give you minus 2, minus 6. So H0 is 0. So in order to hold this inequality is true, that fx is greater than equal to 6, what I should have? What I am getting? I should have hx greater than h0. That means h should be increasing function. Okay, so I will compute h dash x, and I will equate it to, not equate it to, we will have the condition that h dash x is greater than 0, and that will give me the interval. What should be the interval where this is true, and that will help us in computing a. So let's do this. So do you know what we have to do? We have to compute the derivative of this function, and we have to factorize, we have to write it in such a form that gives me some condition that when h dash x would be positive. So let's compute h dash x, quite a lengthy expression. So 4 plus, please correct me if I am wrong. So 4 minus 8 sin x minus 4 derivative of log. So cos x into 1 plus sin x. Then in numerator you have derivative of this thing. So apply product rule. Derivative of cos x is minus sin x. This expression as it is, plus cos x as it is, derivative of this. So this is cos x. So cos square x. Fine. Plus sec square x minus 2 secant x tan x, and the derivative of this constant term is 0. Okay. Now if I can take 1 plus sin x common, this term can be cancelled out. So I know this inequality cos square x is 1 minus sin square x. So I can write it as 1 plus sin x into, so this minus goes here, it becomes plus. Okay, so this expression inside the bracket is sin x into 1 plus sin x plus 1 minus sin square x. So using a square minus b square is equal to a minus b, a plus b, I have this. Right, then we can take this 1 plus sin x outside, and that factor will be cancelled out with this. So what we are left with? 4 minus 8 sin x, and see, I have already made a mistake. Here we had a minus sign and I cancelled it. This was not a product term. We had plus sign here. So that is not possible. Okay. So please look carefully. So this is minus 4. So this 1 plus sin x has been cancelled out. So we are left with minus sin x here. Then plus, from this factor, this has been taken out. So 1 minus sin x. Okay. And in denominator, we have cos x. Okay. Plus sec square x minus 2 sec x 10x. Okay, so if I take 4 outside from the common from this, we have this. Fine. Minus 4. What we have? 1 minus 2 sin x. Any problem? Okay. So I can write it as this plus. Now see, 1 minus 2x is here, 1 minus 2x is here. If I can find somehow 1 minus 2x from here as well. So if I take secant square x common, 1 minus 2, you can see this will be sin, you will be left with this. Okay, so this expression reduces to 1 minus 2 sin x common, then 4 minus 4 sec x plus sec square x, right? And what is this? Sec square x minus 2 whole square. Good. Sec square x minus 1 whole square. So this factor is always positive. Okay. So h dash x will be positive when 1 minus 2 sin x is positive. Fine. Now 1 minus 2 sin x will be positive. One minus 2 sin x will be positive if 1 is greater than this, or you have 1 by 2 is greater than sin x. Yes. Okay. That doesn't matter. It will remain greater than. Oh. Okay. Thanks. So 1 by 2 is greater than sin x. Now sin x is less than 1 by 2 in the first quadrant. When this is possible? When this is true? When sin x is smaller than pi by 6. So when x is smaller than pi by 6. So when x belongs to 0 to pi by 6, this is true, right? And in the problem, what was given to me? X was belonging to 0 to a. So what is a? Pi by 6. Next question, please. So try to understand the technique in each of the problem. Okay, we are using different technique in each of this problem. Now look at this problem. Alpha and beta are satisfying this relationship. Alpha is greater than 0, beta is greater than alpha, so is greater than 0 as well, and both are smaller than pi by 2. Then which of these expressions is true? Now is it a function? Beta sine alpha and alpha sine beta. Are these functions or are these some real numbers? These are some real numbers. So these are not functions fx and gx. Okay, so try to construct some function so that its value at two different points at alpha and beta give you something of this form. So you have beta sine alpha and alpha sine beta. No matter what sign you have, whether you have greater than this or you have less than this, alpha, beta and are positive number. So if I divide by positive number, the inequality is not reversed. So I will have this. Okay. So actually this question is asking me to compute which value is bigger. Fine. Now alpha is less than beta. If I construct a function f like this, sin x by x, if this turns out to be an increasing function in 0 to pi by 2, which is the domain, then alpha less than beta will mean sin f alpha is less than f beta, so that this result will be true. And if this is increasing, if this is decreasing, then I will have this, which means this inequality will hold. Okay, so this is the trick. Okay, you may have several other problems of this form, something like 7 plus e minus 6 and 6 plus e minus 7, something of this form. Okay, so try to construct a function. Okay, so now the question is really asking me to compute whether this function is increasing or decreasing in the interval 0 to pi by 2. So we compute f dash x. Okay, so what is f dash x? X cos x minus sin x over x square. Denominator is always positive. What about numerator? Again, I do not know. So what we will do? We will consider a new function. This is the technique I told you people. Okay. So x cos x minus sin x. And now look at its derivative. So what it gives to me? Let's see if this is of any help to us. So cos x minus x sin x minus cos x. Okay, so this gets cancelled. Now in the first quadrant, sin x is positive as well as x is positive. So this term is less than 0. That means function g is decreasing. That means for x greater than 0, g dash x is less, gx is less than g0. Whereas what is g0? It's 0. Okay, so g for all x, gx is negative. So this expression is negative for all x in 0 to pi by 2. Right? So this is negative means function f is decreasing. Function f is decreasing means since alpha is less than beta, f alpha should be bigger than f beta. That means sin alpha by alpha should be greater than sin beta by beta. So that means beta sin alpha is greater than alpha sin beta slightly. So this option is correct. Perhaps this is option A. Okay. 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 So next problem is, okay, in the same problem, we know what is the relationship between sin x and x in the first quadrant. Between 0 to pi by 2, is sin x bigger than x or smaller than x? Sin x is less than x. Good. So sin x is less than x. So if I take this number to be beta and this number to be alpha, okay, then using the above result, what I will have? Sin at alpha by alpha was greater than sin beta by beta because this function was decreasing. So you have decreasing, alpha is less than beta, so you have this thing. So if you replace alpha by sin x, so sin x by sin x will be greater than, replace beta by x, this. Okay, so this question may be asked. Fine. Okay, next problem. So now a cubic function is given to us and it's given to be monotonic, and then we have to find the possible values of a. So this is the application of that result which we discussed, that when is a cubic polynomial monotonic? When discriminant of the derivative polynomial is less than or equal to 0. So compute the derivative. So fx is x cube plus a plus 2 x square plus 3ax plus 5. So computing its derivative, we get 3x square plus twice of a plus 2x plus 3a. Now we have to find its discriminant. So discriminant is b square, b here is this, a here is this, and C here is this, A here is 3. So B square minus 4AC. Okay, so this is 2 2s are 4. A plus 2 square will be A square plus 4 plus 4A minus 4 into 9A. I'm not solving this because we need to factorize it. We have to find A such that this D is less than or equal to 0. Okay, so taking 4 outside, I'm left with A square plus 4 plus 4A minus 9A. So this must be less than or equal to 0. Now 4 is positive, so dividing by 4, sign doesn't change. So this gives me A square minus 5A plus 4 should be less than or equal to 0. Now factorize it. You know how to do this. So factors will be A minus 1 and A minus 4. So this product should be less than or equal to 0. Now this product can be negative in two ways. Either this is positive and this is negative, or this is negative or this is positive. So let's see what happened then. And that will give us the possible values of A. So factors, if A minus 1 is negative and A minus 4 is positive, this will give me A is less than equal to 1 and A is greater than equal to 4, which is not possible. Okay, now A minus 1 greater than equal to 0 and A minus 4 less than equal to 0. This gives me A greater than equal to 1 and A less than equal to 4. Right? So what is the possible range for A? A can belong to the closed interval 1 to 4. Okay, so this option is correct. Slide please. Okay, then next problem. If the function f from R to R given by this expression, fx is equal to x cube plus ax square plus 5x plus sine 2x